this diagram here, I don't know if you can see it very well. Yeah, more or less, you can see it, more or less. Okay, so this diagram here, this figure here, it tries to present a basic, a primitive web application. What is a web application? What is the architecture, the most primitive architecture of a web application? It consists, this most primitive architecture, it consists in three layers. First layer is the client layer. The client layer is a thin client, usually a thin client. It can also be a thick client, but usually it is a thin client. What is a thin client? A thin client is a client that has a little logic inside, and what that client does is ask things, do requests to a server which does all the work or almost all the work. Okay? This is a thin client. So a thin client is an application which has very little logic inside. So the most part of the logic, the most part of what that application performs is in fact performed at the server side. Okay? The usual example of a thin client is a web browser, a navigator. This is the usual case or the usual example of a thin client. And in fact, web browsers are usually your access point, your door to web applications. How do you access web applications? You could access web applications in other ways, but usually you access web applications through a web browser. Okay? So, in this introductory class, let's think of thin clients. Let's think, of the client layer of the web application as a browser. Okay? I do insist there are other thin clients apart from browsers. Okay? So browsers is or are not the only thin client. There are other thin clients. But usually your access point to a web application is through a web browser, so let's consider web browsers as the usual thin clients for the purposes of web applications. Okay? So we have the client layer, which is a web browser. Then we have second layer, the web layer. The web layer is a web server. A web server that provides some answer to the requests that the client, the web browser, does. So the web browsers will ask something to the web server, and the web server will answer the client, the web browser. How is this communication, or how this communication takes place? This communication in usual web applications takes place using a protocol. You know what protocol I am talking about? HTTP, no? The HTTP protocol. The HTTP protocol is a very particular protocol, which is just a question-answer, let's say a request-answer protocol. Okay? So, client asks something and the web server responds. The web server answers to that request. This is an HTTP. The HTTP protocol is based on that. It's a very simple protocol of question-answer. One of the characteristics, one of the features of the HTTP protocol is that it is a stateless protocol. It doesn't keep the state of the client, which will have some, or which will have some importance later on, because sometimes web applications are quite complex, and they establish some sort of conversation between the client and the web server. So if the protocol doesn't keep the state of the client in that conversation, somebody will have to do that. And of course, that one will be the web server using something called sessions. But today we will not talk about sessions because it would take more time. Okay. So the communication between the client and the web server is performed usually using the HTTP protocol. Okay, the HTTP protocol, which is a very simple protocol of question answer. In fact, HTTP protocol was not created specifically for web application. It was used mostly to retrieve pages from a server, normal HTML pages from a server. Long time before, or some years before, web applications started to exist, the web world existed already. But at that moment, there were no web applications. There were no dynamic pages. What it was there was just simply requests to get some resource from the server. That resource could be an image or could be an HTML page or something like of the sort. Okay. So in order to retrieve an HTML page, it was not necessary a very sophisticated protocol. Just a request-answer protocol was enough. Okay. So the client, the web browser, asked for an HTML page, and the server gave the browser that its HTML page that he had requested, or it had requested. So it was easy, nothing special was required. Okay. However, things got a bit more complicated when web applications entered into the scene, into the scenario. Then things changed a little bit. However, the same protocol was kept. And then it meant that we should make the web server more powerful. For instance, the web server should take the conversation with the client. The state of the conversation with the client should be stored in some way in the web server. As I said, this is called sessions, but today we will not talk about that. Okay. And then what happens in the server, in the web server? So in the web server, when the web server receives a request from a client, what it does is to run a program. To run a program to to answer that request. Let's think of one of those requests. For instance, I'm going to travel, I don't know, from Sarajevo to Barcelona by air, by plane. So I access one web applications of an airline web application, and then I do a request to this application saying, okay, I'm going to travel, or I want to travel from Sarajevo to Barcelona. So what timetable can you offer me? What prices can you offer me? This is a request, okay? This is a request. This request, which are the timetables, which are the prices, these requests come to the web server, and then the web server should answer to this request. How does it answer to this request? Obviously, running a program. This program is called a server. The program that is stored in the web server and that is responsible for for answering a request coming from the client, that program is called a server, at least in Java technology. What I am explaining, what I have explained until now is quite general for any web application. But what I'm saying now, this terminology, servlets, this is a specific of Java technology, okay? Which is the technology that in which I work and which I will present to you, okay? So there is a program in the server that answers the requests, that manages the requests coming from the client, and that program is called server, okay? What does this program do? Well, okay, whatever the request needs. whatever the client needs. But usually, this servlet will need to access a database. For instance, in this case, I'm going to fly from Sarajevo to Barcelona on 10th of February on 10th of February. So which timetables have, which flights you have that day, that particular day, and which is its price. Of course, the servlet, what it will do is to access to a database to make that consultation, to retrieve those flights, okay, and those prices. This leads to the third layer of a web application, which is the enterprise information system layer, which is composed at least of a database, and it can also be composed of other sort of applications, legacy applications they are called sometimes, because they are applications that are specific of a company, are applications which have in general nothing to do with web applications, but the web application access them. They are called, in general, they are called legacy applications. Legacy applications. But one of the legacy applications which is most used and which is unavoidable in a web application is a database. So at least in the enterprise information system layer, at least we will have the database, and maybe other applications, legacy applications, but at least the database. A web application which has not any database is a very, very simple web application, and probably an absolutely useless web application, probably. Maybe not always the case, but usually any web application has to access to a database, okay? So then we have these three layers. And I would say that these three layers are the minimum layers that are necessary in order for our applications to work properly. However, these three layers are not satisfactory at all, because this server, this program in the web server, is responsible for two things. First thing, the logic of the application. So how to retrieve the flights that go from Sarajevo to Barcelona that day, and what prices those flights have, etc. So this is the logic of the application, okay? So servlets, these programs here that manage the request from the client, must deal with logic aspects, but also must deal with presentation aspects. Because of course, when this request has been managed, an HTML page, usually an HTML page, it can be other sort of pages, for instance XML or whatever, but let's put a simple thing in HTML pages. An HTML page will be sent back to the client. Of course, that HTML page will have some sort of presentation, of course. It will have tables, it will have divs, it will have forms, I don't know. It will have some sort of presentation. It will have some blue color or some red color or whatever, or some window here, okay? It will have some sort of presentation. Who will determine that presentation? Who will program, who will prepare that presentation? Servlet will. It's a program that is executed. So servlet, in this model, in this three-layer model, has two very different responsibilities. First responsibility, dealing with the logic of the request, of the logic of the application. Second responsibility, dealing with the presentation of the application, okay? The presentation of the page that will be sent back to the client, okay? This is absolutely unsatisfactory. In software engineering, we tend to separate concerns. Separation of concerns is one of the bases of software engineering. Separation of concerns. Here, with this model, we have everything mixed up, everything cracked in the same in the same program, in the same server. So this is not true. For this reason, there is another model, which is this one. In this model, the web server, in fact, has split into two. On the one hand, we have the servlet, the same program as before, which is mostly responsible for presentation aspects, okay? For getting the parameters of the request and sending back a response to the client. This would be the main goal, the main responsibility for the server. But now we have another component here, which is Java beans, in fact Java classes, which will be responsible for the logic of the application. Okay? So now, let's have a look to the overall picture. We have a web browser that performs a request, that makes a request to the web server. This request is, for instance, the following. I want to fly from Sarajevo to Barcelona, 10th of February of 2008. Okay? This is the request. But the request could have been, I want to fly from Sarajevo to Madrid on 20th of March of 2008. Or it could have been, I want to fly from Sarajevo to Rome on blah, blah, blah. Okay? So, there is no only one possible request. Then the request global is the same, I want to fly. But from where to where? Which day? This from where to where and which day, these three things are the parameters of the request, okay? Think of that, the parameters of the request. What are the parameters of the request? Well, the elements that the servlet needs in order to manage the request made by the client. Which are the parameters in this specific case? From where? You want to fly, okay, but from where? To where and which day? Okay? Three parameters. From where to where and which day? This request with this carrying these three parameters comes to the web server. And there is a servlet which is executed in order to manage this request. What does this server do? This servlet, what does this servlet do? Essentially, it does two things. First thing, to get these parameters of the request, and to pass them to some Java classes, which will be called Java beans. A Java bean is not the same as a Java class, okay? It's not exactly the same. But at this level of detail, at this very coarse level of detail, we can say what is the same, okay? So, the servlet will take the parameters, will extract the parameters from the request, okay? Extract the parameters from the request, and pass them appropriately to some Java class or some set of Java classes that will take the responsibility for the logic of the application. What those Java classes or Java beans will do, they will access the database in order to know which flights go from Barcelona or from Sarajevo to Barcelona that day. And the response will be passed again back to the server. And the server, with that response, with that answer made up by the Java beans or the Java classes, with the help of the database, will compose a response, an HTML page, which will be the response that will be sent back to the client. Okay? This is a web application. Is this web application, is this architecture, is this model better than the last one? It is. It is because here we have clearly separated two different things, two different concerns. Dealing with the web aspects on the one hand, which are the web aspects? Presentation and partnership, okay? First thing. And dealing with the logic of the application, second. Well, this is very beautiful, this is very nice, but to achieve this separation in a proper way is not that easy. So we have to apply some design patterns, okay? Some software engineering design patterns. In particular, to achieve this separation properly, it's not just necessarily say, okay, we'll put some Java classes. No. I mean, we have to know how to do that, okay? In order to make this separation properly, this separation of concerns properly, we need to apply, as I said, different patterns, design patterns, software engineering design patterns. In particular, we will apply, not today, but maybe in May or maybe during your term, your professor will tell you how to apply these patterns. We should apply two patterns, at least two patterns. The MVC pattern, which is model view controller pattern, MVC pattern. This MVC pattern, this model view controller pattern, model view controller, MVC, model view controller, yeah, model view controller.
How do you spell view actually?
The model is this, the view is this, and the controller is another component which controls the relationship between these two. So here would appear another element which would be the controller that takes responsibility of the communication between the view and the model. Okay. So we will use, or we should use, the model view controller pattern. And in fact, there are some frameworks that, if you program web applications using those frameworks, you have that for granted. So you have the infrastructure in order to program, to create, to design that web applications using this model view controller pattern. I will tell you two of these frameworks. One of them is Struts, the other is Spring. Struts and Spring. They are two frameworks which are responsible, or which are able to provide this separation using the model view controller pattern. In its turn, the model view controller pattern is based on another pattern which is called front controller. How does this pattern works? So it receives.
Just before you continue, so actually Struts and Spring are what exactly definition?
Okay. Struts and Spring are frameworks. So what's a framework? A framework is a hierarchy of classes that you can use and you can specialize in order to design, in this case, a web application. Okay. So these frameworks are intended to what? Are intended to give you the infrastructure you need in order to design a web application using the model view controller pattern. So that separating on the one hand the model, on the other hand the view, and the controller just controlling the interactions and the communications between both. Okay. These frameworks, or these sort of applications, how do they work? These sort of applications, how do they work? Applications in which we use this model view controller pattern, how do they work? The request is sent to the controller part. The controller takes the parameters and send them to the model, which is composed by Java classes. And well, let's at this moment let's consider equivalent Java classes and Java beans. Okay, they are not exactly the same. In fact, Java beans and Java classes have several features.
Yes, that's why I was asking. Is Java so?
Java beans is a subset of Java classes. Okay, so Java beans are Java classes, but on top of that they have several features, several additional features. But I think that now it's not the moment to. I will give you, if you like, some material. In fact, you have some material of introducing web applications in the Java universe. I already sent you that, and you have that in the virtual campus. And in the next, I am just finishing the preparation of this material, but I think in the next few weeks, I can, just a moment, in the next few weeks, I can send you some material about Java beans. Yes, I mean, and you can put it if you like in the campus. Then there's a question.
What is virtual campus?
Well, I'm talking about virtual campus. For me, I call virtual campus to a web tool to which the students can access and see all the material of a specific subject, or in fact of all the subjects of the degree. This is a virtual campus for me. And in fact, I know, how do you call that?
Distance learning.
Learning?
Distance learning.
Distance learning system or web system. Okay. So in your distance learning web system, at the moment, you have the assignment, the object-oriented programming assignment that I have been discussing during this week, and you have also another material which is an introduction of web programming, which is more or less what I am telling now. But with a lot of examples, and okay, so you have that. If you like, you can consult that. But there are some things, because it's a very basic introduction, there are some things you cannot do. For instance, tags, Java beans, patterns. For instance, model view controller pattern or other patterns. This is not there. But I can, during the semester, I can send you that material if you like. Yeah, I will send you that material. In fact, in internet there are a lot of material about that. But I can send you mine. It's all in English. I only create material in English, at least for the master courses. For the bachelor degrees, I create or I write material in Catalan. But for master courses, for master degree, everything I write it in English. So you should have no problem. So the request, this is the client, okay? The request, let's put it another way. Let's put it here, the client. This is the request. The request gets the controller. So all the requests are the same. All the requests keep the same servlet. This is a servlet. This is the specific use of the model view controller pattern, okay? Using frameworks as struts or as Spring. If you use struts or Spring, you will end up doing something like this, okay? But with the help of that framework, you don't, for instance, you don't have to program the controller separate because it's already programmed by the framework. You just use it, okay? So, you are the client, you send a request, you always send the request to the same controller, and the controller is responsible for retrieving or modifying some part of the model. The model, in its turn, is composed of Java classes that access a database, okay? And the controller is also responsible for choosing a view. A view that will be sent back to the client as a response. Choose a view and add the information sent or computed, calculated by the model, by the Java classes. So let's have a look to how this would work. First of all, the client sends a request to the controller. When you use this framework, or when you use this pattern, model view controller, you always send the request to the controller. If you don't use this model view controller, then no. Then when you want to know the flights from Sarajevo to Barcelona, you send a request to the server, calculate flights, okay? But when you want to know, for instance, the list of all flights, whatever destination provided by the airlines, then you make a request to some other servlet, which can be, for instance, calculate all flights. Okay, can you see the difference? However, when you use the model view controller, you do all your requests, you send all your requests to the same controller. And then it is the controller who is responsible for knowing which specific part of the model you want to change or you want to retrieve. How can he know that? Well, he can know that because one parameter of the request will be the specific action you want to perform. So you will send, the client will send a request saying, okay, the action I want to perform is to know flights from blah to blah, okay? From Sarajevo to Barcelona. So this is one action. A second action could be, I want to cancel a flight. This is a second action. So the request will be sent to the same controller, but with a different parameter, which will be the cancel action. Okay? First will be the calculate flights action, and then would be the cancel action. Okay? What does the controller with this request? First of all, chooses a part of the model that must be retrieved or modified. For instance, if it's a cancellation, it's of course a modification of the model. If it's a consultation, a retrieval, for instance, how many flights or which flights go to, then it's a retrieval. And also chooses the view that will be sent back to the client. According to each action, there will be a different view. Of course, if the action is calculate flights from Sarajevo to Barcelona, the view will be will be a table, for instance, and in each row of the table you will be one particular flight with the timetable and the price of that flight. Okay? This will be the view that must be sent to the client, must be sent back to the client in the case that the action is to calculate flights. If the action is different, for instance, the action is a cancellation, then the view which should be sent to the client would be something as simple as your flight reservation has been cancelled. This would be the view. So who chooses one view or the other? The controller does. Okay. We could say this is 2A and this is 2B. 2A and 2B. 2A, retrieving the model. 2B, choosing the view. So the model, the Java classes, what will they do? Will they do some logic, and they will consult the database. Okay? They will consult the database. They will modify the database if it's a modification, for instance, a cancellation of a reservation, or maybe they will retrieve some aspects of the database. For instance, the flights from Sarajevo to Barcelona. Okay? Of course, then this information calculated by the model will be sent back to the controller, or this information will be sent back to the controller, and finally, this information will be added to the view. Of course, the view in general is to write a table with all the flights, but which is the information that must be in that or on each row of that table? Which is that information? This information has been calculated by the Java classes and now will be incorporated, will be added to the view by the controller which has received that information. In this case, or with all of this, the view has now or is now complete. On the one hand, it has the, let's say, the pattern of the view page, table, and now we know also the contents of each row of the table, which have been calculated by the model and sent back to the controller and sent to the view. Okay. So this view with the model information will finally send back to the client. This will be the last point number 6, step number 6. It will be sent back to the client, and then the client will be able to see the information requested. Okay? And this is very elegant. This is very elegant because the view is independent from the model. And there is another component, which is the controller, which takes the responsibility of communicating both and choosing which action should be executed, so which part of the model should be executed, no? In fact, here, within the model, if we want to be strict, we have to distinguish in fact, the actions are part of the controller. No? The controller chooses also actions, no? Actions that modify or that retrieve the model. Well, these are just minor things of this big picture. Okay. So this is the essence, the idea of the model view controller pattern. I would say that if you want to design a web application, an elegant web application, a scalable web application, a reusable web application, you should use some sort of framework similar like this, or some sort of architecture similar to this one. And in using the Java technology, what frameworks can you use in order to make easier for you the programming of an application in this way, of a web application in this way? As I said before, you can use the struts or the string, or there are other. Well, I know this couple, not this two. Okay? In the Java world, in the Java, using Java technology, okay? Can you more or less understand the idea? No? And then there is another important thing. We have seen, this is the model view controller pattern. But what happens here? Here we have a problem. Houston, we have a problem. Can you foresee the problem we have there, that corner of the picture?
Communication with the database.
Sorry?
The communication with the database.
Yeah, the communication with the database is complicated. It's complicated. What? separate some knowledge.
It can separate in a different model by itself, but when you give only the class is calculated.
Yeah, okay, well, this would be,
this between.
yeah, okay, yes, in fact, it's this. I call this the separation between, or more than separation, the matching or the way to connect the connection between the object-oriented world and the relational world. Because usually, not always of course, but usually the database you have there is a relational database. Well, the string, well, more than that here, hibernate, and also, well, with the difficulty, well, the difficulties. I think that article, in my opinion, is a bit exaggerated, but of course he knows better than me because he has written a lot of books about G5E. But well, in any case, well, let's not right here G5E. Okay, so let's have a look again to the picture. But just to this corner of the picture. This corner of the picture is critical. It's critical because all of this is object-oriented, but that corner usually is not object-oriented but relational. More than that, you can have a web application. And one very good, very bright, very intelligent idea would be to separate completely the web application from the persistence method you choose for that web application. So that you have one web application that can be implemented, or sorry, can be deployed in a relational database, in some XML files, or maybe in an object-oriented database. Okay. So this corner is a critical one. What we should do here is to abstract the web application from the persistent technology that we use. This is what we should do here. How do we do that? Again, we apply a pattern. Another pattern. A pattern which is different from the model view controller pattern. There is another pattern which allows us to separate the web application from the persistence technology we use. That pattern is called DAO. Data Access Object. This pattern allows us to define a couple of classes, allows us to abstract the access to a database in terms of a couple of classes, a set of classes whose implementation will do the access.
Question, Professor, under the MVC umbrella. So DAO is used under the MVC umbrella.
Yes, of course.
And when I was MVC, but just only solve that part of the problem, I was
Exactly. And in fact, you can use DAO without using MVC. I mean, there are two different patterns for two different situations. The usual thing would be to use, in my opinion, the most relevant thing would be to use the MVC pattern and then to abstract the access to the database, use the DAO. So the DAO pattern provides or defines some classes, some, in this case Java classes, which will abstract the access to the database. Those classes, now I will erase this. For instance, I don't know, in a library, I don't know, in a bookstore, for instance, we can have the class book DAO. extends, whatever, I don't mind now. This is not C++, this should be Java. Well, in fact, this is just a very abstract codification, so it's nothing, it's not like which sort of operations we would have here. Operations, for instance, insert book, which would accept a book as parameter, and that book would be inserted into the database. For instance, find book by ISBN. Now here we would provide an ISBN, and this operation would provide or would give us a book. For instance, find book by author. Here we would provide a name of the author, and that would give us a list of books written by this author and that we have in the bookstore, etc. What's the idea of this? The idea of these sort of classes is that we don't have to deal with the database. All the access to the database will be hidden here in these classes. And if we apply a factory, which is another pattern which is applied with the DAO pattern, so on top of DAO pattern we use the factory pattern. If we do this, then we are able, with little effort, with small effort, we are able to change the persistence technology very easily. We are able to change from one persistent technology to another persistent technology, for instance, to one, I don't know, Postgres SQL, and DMDs, to, I don't know, Oracle database server, very easily, or to Postgres SQL to the XML, or to, I don't know, to some object-oriented database technology. With the small effort, if we use this pattern with factories, which is something I won't explain now, but I will give you some material if you like, and maybe I can explain this. I don't know. We will talk with Professor Dix, with Harris, with Ismail, we will talk with them, or maybe with you. I don't know whoever is responsible for this subject. I will talk to them or to you, and then we will decide what do I explain in May. But if you use the DAO pattern with factory, then it's very easy to change from one technology to another technology. One persistent technology to another persistent technology. There are some frameworks which are related to this part, in the same way as I said before that the Spring and the Struts were frameworks that provided this MVC, an implementation of this MVC pattern, model pattern. There are some other frameworks, well, same frameworks or technologies or APIs, which allows us to work with this DAO pattern. I will provide here two. Hibernate in GPA. Both frameworks, or both, well, Hibernate is more a framework, but GPA is just an API. Both things, both technologies, what they do is to provide a mapping between the object orientation to the relational database. Okay? So this is a particular case of what I have explained. Okay? A particular case. This particular case is to map the object-oriented world into a relational database technology. Okay? This mapping is done easily using the Hibernate or GPA. GPA means Java Persistent API. Is a persistence API that allows you to abstract from access to the database. So the access to the database is performed completely by that API. Okay? So you don't have to care about it. So this is the, for me, a good picture, a good overall picture of what it is all about. So first of all, the MVC pattern to do a good software engineering of a web application with the controller component, with the view. The view will always be, or almost always be, GSP pages. GSP pages are servlets. Let's imagine, or let's think of them as pages, as servlets. So, and then the model, which are Java classes. But then this model accesses the database. How does it access the database? Because we have here a problem, a stress, because the model is object-oriented, the database usually is relational, so we use this pattern, DAO, in order to smooth this connection. And how this pattern, are there some helps in the market in order to implement this pattern? Yes, here on Hibernate GPA and a lot of more, but I can't possibly know about all the technologies. It's a vast world, this is a huge world, and I have focused on some technologies and I have tried to study them well, but in some other technologies I don't know them, or I don't, of course I'm a bit familiar with them because I have heard something about them, but I can't know everything about them. So I know these two hibernated GPA, and they are in the same way as before I talked about struts and strings. Okay, so this would be the big picture, and okay, and technologically, practically, what we can use in order to implement this, in order to create a web application in the Java world. Well, first of all, we can use an IDE, which can be Eclipse, or in my opinion, even better, NetBeans. NetBeans is an IDE which helps us a lot in order to implement a web application. Then you need a web server. You need a server that accepts requests and that sends these requests to the servlets. And that web server, in fact, it's not exactly a web server. It can be within a web server, or even without a web server. In fact, it's called a servlet container. More than a web server, it's called a servlet container. One very popular servlet container in the world of Java is Tomcat. Now, there is another one which is called Glassfish. Glassfish, which is the servlet container, the Java reference, sorry, the Sun reference implementation, for servlets and for Java enterprise applications. This is called Glassfish. Glassfish. I am starting to work with Glassfish now, but until now, I have worked with a very popular servlet container which is called Tomcat, and which works very, very well. Okay, so let's have a look, if you like, how would this work from the technological or from the practical point of view. so let's. Okay, this is Tomcat. I don't know Okay, so this is the welcome page of the Tomcat welcome page. To download Tomcat is extremely easy. You only have to go to the Apache Tomcat page and download it. And its installation is as simple as decompress the file you get. You get a file, you get an archive, you just decompress it to a certain directory, and that's all.
Just if they want, for example, not to type just if they don't want to type the port, they have just to change the port to 18.
Yeah, exactly. You can, but I have kept this port. Look at that, and in order to access the web the welcome page, we just write localhost, which is the IP of my localhost, and then the port, which is 8080 by default. But of course you can change this port. I haven't changed this port because I also would use Apache, and then Apache takes the port 80, which is the default, and then I prefer Tomcat to access the port 8080. But of course you can change that. Okay. Here in this page you have a lot of information. Here, well, you can see it, but well, it doesn't matter. But it's okay. Here we have a lot of information. In particular, the Tomcat documentation. It's very nice. Here is the Tomcat documentation. You can find many things here about the Tomcat, how Tomcat works. Another thing important about Tomcat is how it is structured. Can you see it? Can you see it now?
Yes.
Okay, this is the structure of the Tomcat application. In this structure, there are some files or some folders, sorry, which are of importance. Well, of course, all of them are important, but there are some of them which I think are important for you to know about from the very moment. Which are those folders? First of all, bin. Where is the bin? Here. Bin folder. In this bin folder, you will find the scripts in order to start up Tomcat. Okay. So you move to this folder, and then you execute the command. You run the command startup. Okay. Startup, and then the Tomcat server, the Tomcat servlet container. This is its official name, a servlet container. What the servlet container means? It's an application that can run servlets, that can execute servlets and manage requests made by a client, probably a remote client, by the HTTP protocol, and manage them using a servlet, and then sending back a response to the client. This is what the servlet container means. Okay. So we have here the startup and also the setup. The stop script for the Tomcat. And another one which is very important is web apps. This is very important, this folder, because in this folder This is the folder in which you will deploy, in which you will send, you will copy your web application, okay? So you will write a web application, you will compact it into a jar file. So, of course, your web application will be composed of many files, it is clear, no? So, all these files will be compacted, will be compressed in just one file, which is a jar file. And that jar file will be put, you will put it in this folder. And then the application compressed and compacted into a jar file and put here in this folder is automatically accessible by the Tomcat, okay? Now we can make see an example, a very fast example.
So that's why we use and actually to deploy them.
Yes. Yes, we can see now. We can see now a very two examples. Okay, two quick examples, and you will see how it works. Okay. And that will be the end. Okay, I promise. I know that it's a bit late. I mean, we have started at 9 o'clock, maybe a bit later on because I was having some problems with the solution of the computer. But in any case, it's a bit late. But just let me finish with these two examples of how a very small web application and a very tiny web application could be deployed and could be seen in Tomcat, okay? Just let's try to answer first of all a question. That question would be, which is the structure of a web application? Let's imagine that for example, let's imagine that our web application is called example, okay? Example. So, example, how is it structured? Example would be, could be a folder, and within this folder, we could have as many GSP files as we need. Okay, we haven't said what a GSP file is. A GSP file, yeah, because well, we haven't seen how a servlet is programmed. And a servlet, you can remember that is a program which is executed in the server and which accepts requests and manages them. That program is a Java class. Okay, is a Java class. However, since it's quite annoying to write Java classes all the time and to write, just to write a set of methods, and sometimes this is a bit annoying. So, in order to make things easier, it is possible to create GSP pages. GSP pages are HTML pages, normal HTML pages, but within those HTML pages you have from time to time just a bit of Java code, okay? A script that is a bit of Java code. That Java code, in fact, the whole GSP page is automatically translated by Tomcat into a servlet, okay? In this way, we don't have to write servlets, which is a cumbersome thing to do. It's a difficult thing to do. It's a complex thing to do. Now the method to get, now to post, now I have to use that, I don't know what. I have to declare a servlet context, a page context. So it's a bit difficult. So instead of doing that, we just write an HTML page. And in order to use, or in order to make that HTML page dynamic, we put some Java code, okay? So an HTML page with Java code is called a GSP page. Okay? Usually, web applications, the web part, the web aspects are built with GSP pages. Okay? So here, this is a folder, the folder examples. Within this folder, you can have as many GSP pages as you like, as many HTML pages as you like, as many images, as you like, okay? You can have this right below the main folder, okay? Right below the main folder. Or if you like, you can have this within another folder. For instance, you can have here a folder called web, and within the web folder you can have all the GSP files, the HTML files, or the image files, okay? You can do that without any problem. Okay. Following the structure of a web application, you have a folder which is called webin. Within this folder you have a configuration file. This file, web.xml, is compulsory. Very simple web applications don't have that. But usually when you write more complex web applications, you need this. You need this web.xml, which provides some configuration of the web application. This is called the deployment descriptor. This is called deployment descriptor. To deploy a web application means to make it available for everybody. Everybody that can use it or that wants to use it. To deploy a web application is made it available within a servlet container to everybody. Okay, this is what deploying a web application means. Okay. So in order to deploy a web application, if it's a bit difficult or if it's not very simple, you need this web.xml. And then you have another folder called classes and another folder called lib. This is the structure, the usual structure of a web application. In the folder classes, you will have all those Java classes that you need in order to execute this web application. Those classes are not here, are not JSP files, of course are not HTML files. They are .class files, which are put here, which are inserted or contained here in the classes folder. They can also be contained here in the lib folder as a jar file. A jar file is a file that contains a set of classes. Okay, so this is a web application, and now what we will do with this web application is to compact it in one file. Okay, of course this has a lot of files. We compress all these files in just one. Okay, how do we do this? With this instruction: jar CVF. The V is not compulsory. C and F are compulsory. This instruction, if we are located within this, if our prompt is in this folder, just executing this command. Sorry, this is Word. By default, the extension for a web application is Word, not jar as I had written before, Word. So this command will create the file example.word, which will be just one file containing all this structure, okay? And then this file can be In order to be deployed in the web application, this file can be copied into the web apps directory of Tomcat. So we can do copy cp example.word cp or copy whatever instruction you need in your operating system. Copy example.word to Tomcat. This is the Tomcat directory. This is not the Tomcat. This is the Tomcat directory, the Tomcat folder. .web apps. This is the directory web apps within Tomcat that we have seen before, and where all the web applications lay. Okay? What will happen now? The example.word will be inserted into the web apps directory of Tomcat, and then you will be able to access this example web application. In which way? In this way. HTTP plus localhost 8080, and then what? But example, and that's all. Well, example and maybe f.gsp. You need, in each web application, you need to have a welcome page, a first page. If that first page is called index.html or index.gsp, you get the direct access just with the name of the web application. If not, if that welcome page is called f.gsp, for instance, then you have to put here f.gsp. Okay? You can choose another name for the welcome page and just put that name here in web.xml, but these are the details that I want to explain now. And now I'm finishing just with just one example. I think one example will be enough. Let me see. Okay, so here is this is the way it looks, the development folder of a web application, of a very easy web application. We have the directory source, which contains the Java classes of that web application. We have the directory web, which contains the GSP pages of that web application. Okay? And we have the build.xml file. The build.xml file is a file that contains the instructions in order to deploy this web application. We use an application called ANT, A-N-T, that small insect that exactly, probably. So we need that application, which is called ANT, in order to interpret, in order to read and to execute this build.xml file. Okay? For instance, we have here the first target. The first target is to prepare the build directory. The build directory will be the directory that contains the structure of the web application and which afterwards will be used in order to create the the .word file. Okay. So first of all, we create a directory which is called build directory. This is performed by this target. Are you familiar with the make application, the make build tool? in C++, in the C++ world. Are you familiar with it?
Linux uses this all the time.
Sorry?
Make usually Linux uses actually.
No, I'm sure you also use it. I mean, your IDE probably use make too. However, you don't see exactly. Yeah. The make tool is a tool that is able to compile and to build your C++ application. Okay. Probably you use it in your, well, I'm not sure, but probably in your IDE you may use it. It's a quite a standard application or tool, no? Build tool. So Ant is the same, but more standardized because it uses, instead of a make file, the make file is not a standard file, is not an XML file. The build.xml is a standard file. Okay, it's an XML file at least. Okay, it contains a set of targets, and these targets are necessary in order to build and to deploy the web application. That's the idea. For instance, let's see how. For instance, here we have the instructions to compile the Java classes. Here we have the target compiled, and these instructions allow the compilations of the compilation of the Java classes that compose the web application. Okay. You have all this material. Okay, I send it to you, and you have it in your virtual campus, in your distance learning campus. Okay. And now, how would you create the Word file? The Word file would be created with these instructions. And when the Word file is created, this is very interesting. When the Word file is created, it is called x52.word. Okay? When this file is created, it is copied to the web apps directory, and it's already deployed. So this file, build.xml, has all the information in order to deploy the web application. Let's do it. It will take us just a moment. We just run Ant, okay? First of all, look at the contents of the directory. It has just 5 files. You see it. Build, XML, DB, README, SRC, and web, sounds like web. Now we write Ant. Okay? The build and the deployment is processed. So build has been successful. And now let's see the contents of the directory. Can you see that a new folder called build has been constructed? This folder has been constructed by Ant, and it contains all the classes that have been compiled. So the .class file, which is the result of the compilation of the classes that were here. Okay, and we have this Word file. This Word file is the web application that can be deployed, and in fact it has been deployed because it has been copied to the web apps application of Tomcat, folder of Tomcat. Let's have a look to this file. JDBF X. In this case, yes, I have at the root of the web application, I have a form param.html, okay, you see that? Form param.html. I could have also here .gsp file, which would be converted directly to servlets, to Java classes by Tomcat. But at this moment I don't have any GSP file, I have just this HTML file. And I have the webinf directory with the web.xml and the classes folder, which has a parameter.class. The parameter.class is a servlet that will be executed within this web application, okay? It's a servlet. This servlet has been compiled, originally it was a .java file, it has been compiled by Ant. has been put into the build directory, and then those the files that were in the build directory have been moved to this directory within bar classes. Okay. So now we have this web application which is called x52.5.2.word application, and now we can execute it. How we will execute it? Well, let's go to Apache Tomcat. Just let's have a look to the web apps directory. Okay, this is the directory that I have created now. This has been copied here in web apps. This has been the application, the web application that I have created now. It has been copied to web apps, and Tomcat has been decompressed this file, which is of course a compressed file, and here is the folder x5.2, which contains this file decompressed. So now we will execute this web application. I am finishing. Okay, so localhost 8080, and now what should I put here? x5.2. Okay, I have a problem. The requested resource is not available. Why?
Because your index file is not different.
I don't.
Your index file is different. It's not index file anymore.
Exactly. I don't have any index file. I had a file called formparam.html. Even if with this formparam.html I could define it as a welcome page in the web.xml file, but I haven't done that, so the application doesn't know. Okay. So now if I write here formparam.html, now it works. Okay. Well, the meaning of this is in Catalan, and the meaning of this form, it's a bit funny. It's something political of Catalonia, but it doesn't matter now. The point is that I will write here my name or anything, Joseph Ribo, and then I will click or I will check two of these options, and it will send it. Okay. That servlet, which was called, I think, parameter.class, you remember that? It was one of the files I had in the web application, has been executed. It was a servlet very simple, just to make an example, just in order that students that start in the world of web applications can start to learn. So it was a very simple servlet, and that very simple servlet, what it did was to extract the parameters of the request. In that case, the parameters were my name and those couple of boxes I checked. Okay, those were the parameters, and those parameters are shown to the client and shown back to the client. This is the only purpose of this servlet. And here it says capture of the parameter names. The first parameter has the name nom. Nom is it means name in Catalan. And the value here is the name of the parameter is nom, and the value is Joseph Ribo, which is what I have written. And the two boxes that have been checked are PSC and CIU. Okay. So the only thing it has done, this servlet has been to read the parameters and to show them back to the client. Okay. But this is an example of how a web application can work. Okay. So. Sorry, because I know you are tired. At least I am tired. I guess you are more tired than I. So thank you very much for everything. It has been a good week for me, a marvelous week here. And if you like, and if the faculty likes, for me it would be perfect. All going well to come back 1 week on May, some week in May, and to explain in more detail, of course, on the detail that I have explained to you today, some specific aspect of web applications, maybe some pattern, DAO pattern, Hibernate, struts, I don't know, whatever, or Java enterprise applications, G5E, I mean, whatever seems interesting for you and is in your program or in the program of the subject. I only work at the moment. I'm only working with Java technologies, so I will not be able to